Hello, students. So some of you might remember this problem from IMH2. And the way that we looked at this problem last year was using geometric sequences, but let's talk about it this time with a recursive formula. So the problem is, or the situation is, that your parents invest $10,000 in a college fund on the day you were born. Then every year on your birthday, they add $2,000. The fund also earns 8% interest compounded annually. So how much will be in the fund on the day you turn 18? So we start off, so I'm going to say U sub 0 for just the initial amount. We start off with 10,000. And then on the day you're born, so your first birthday, this will have earned interest, 8% interest. That's an amazing fund if you're getting 8% interest. So 100% plus 8% interest, and then they add 2,000. At the end of the next year, all of this is getting my 8% interest, so it'll be U1 times the 8% interest, and then we're adding 2,000 again. After the third year, we'll have U2 will earn 8% interest plus 2,000. So we could say our U sub n is going to be the previous term times 1.08 plus 2,000. So we want to know on the day we turn 18, we want U sub 18. So let's look at our calculator for this. So in my calculator has a sequence mode that is going to be super useful for us here. So I'm going to go into sequence mode. So currently I'm in function, so I'll come into sequence. Whoops. All right. And now I'll go into my U sub n. I'm going to clear out what's previously here. Okay. So our starting n, we could say is 1. That's fine. That's our first year. And our U sub n is going to be our previous term. So I'm going to go into alpha trace to get my previous term. So that's going to be U of n minus 1. And then we're going to multiply this by 1.08 for my 8% interest, and then add 2,000. Our first term is going to be the 10,000 times 1.08 plus 2,000. Okay, so now I can come into my table. All right, so notice I have started here with my table starting at -7. I really want my n value to be 18. So table settings, let's go up to 18. So at the end of 18 years, here's my value. When I go over to the right, notice I can see even more. So after 18 years, I will have, let's drag this over, $114,860.68. So this is a really handy way to use my recursion formula. I have also showed this in the notes, how we could do it with a geometric sequence as well. So let's look at that a bit. So if I continued this, if I had written this term out, I would have had 10,000 times 1.08 squared plus 2,000 times 1.08 and then plus 2,000. So if we look at that, then we'll see that we had, if I took this whole thing, multiplied it by 1.08, I would get this line, add 2,000. By the time I hit my 18th year, that 10,000 would have been multiplied by 1.08 18 times. And then I would have this first 2,000 would have been multiplied by 1.08 17 times, and so on down to 2,000. So this is just a constant. This ends up being a geometric series that has a first term of 2,000 and an n value of 18. So this bit, I could use my geometric series formula and then add my 10,000 times 1.08 to the 18, and you'll get exactly the same value.